Today we're going to look at adding and subtracting and multiplying radicals. You can add and subtract radicals in the same manner as adding and subtracting monomials. You can only add or subtract like terms or radicals that are the same. Here's an example of two radicals that it would be fine to add together. What you're looking for is to see that both radicals have the same index. Here both have, or both ones are the cubed root. And you also got to make sure that the radicand, what's underneath the square root, is also the same. If you see those two things, the same index, the same root, and the same thing under the square root, then it's okay to add these together. So these two we could add together. The root part kind of acts like a variable in that it stays the same. What you add together is the numbers outside. So 2 plus 6, the two numbers we have outside the radicals would make 8. So the answer would be 8 cubed roots of 3a. Here's some examples of things you could not add together. These ones aren't okay. In our first example here, we cannot add these together because they have a different radicand. The stuff underneath the square root is different. Here it's a, here it's 3a. You got to have exactly the same radical in order to add them together. So these two can't do it. Same with the second example on the bottom. This one we can't add together because this one's a cubed root. This is just a square root on the second one. Although the stuff underneath the square root, the radicand is the same, the index is not the same. We cannot add this one together either. So everything's got to be the same in order to add them together. Let's look at an example on your note sheet. Number 11. They want us to be able to add or subtract these radicals here. Now notice first that all of them are just square roots. There's no index for any of these, so they're all being the square root. That's good. Problem here is none of our numbers right now are the same. 12, 27, 48. We need that number under the square root to be the same in order to add those together. And right now they're not. So right off the bat, it appears maybe we can't add or subtract or do any simplifying here. However, if you remember back to what we did with simplifying radicals, possibly there might be some here we can add together if we simplify first. So let's look at our first one, 2 square roots of 12. Can square root of 12 be simplified? Well, let's see. Is there any perfect squares that divide into 12? Yeah. Square root of 4 and square root of 3 would be a way to simplify square root of 12. And we know square root of 4 is the same as 2. So another way to write this one would be 2 square roots of 4 times square root of 3. All right, let's go to our next one, square root of 27. Can we simplify that at all? Well, let's see. Is there any perfect squares that break up into 27? Yeah, there is. Square root of 9 is a perfect square, and 9 times 3 is square root of 27. So this one we could write as square root of 9, square root of 3. Let's go to our last one. Any perfect squares go into 48? If we start thinking through our perfect squares, 4 does, but there actually is even a bigger one. Square root of 16 is a perfect square that divides in 3 times. So we're going to write this one as 2 square root of 16 square root of 3. All right, let's do some simplifying now. We know square root of 4 is the same as 2. Square root of 9 is the same as 3. And square root of 16 is the same as 4. Doing a little multiplying now. 2 times 2 is 4 square roots of 3. 3 times 3 is 9 square roots of 3. And 2 times 4 is 8 square roots of 3. Can we do some adding or subtracting now? Yes. All our terms have a square root of 3. It's the square root, and all of them have a 3 underneath the square root. Those are like radicals, so we can add these and subtract these. And remember, when you're adding and subtracting, you go from left to right. So here, 4 minus 9, that's going to leave us with negative 5 square root of 3. Add 8 to that. Negative 5 plus 8 is 3 square roots of 3. And that's the answer. So all that stuff on top simplifies down to 3 square roots of 3. Okay. Why don't you kind of give number 12 a try for tomorrow, and we'll check that one in class. Let's look at some multiplying. What do you do when you multiply radicals? You're going to do the same thing you would if it wasn't a radical. Here you see you got a binomial, 2 terms times another binomial, 2 terms. So you want to go through and distribute. Think of that FOIL acronym: first, outside, inside, last. If we multiply, we should get the answer here. So let's do that. If we take 3 square roots of 5 times 2, when you're multiplying with radicals, you want to multiply only numbers outside the square root, or outside the radical with numbers outside the radical, and numbers inside the radical with numbers inside the radical. So here, when we multiply 3 square roots of 5, we're only multiplying the 3 and the 2 because both of those numbers are outside of a radical. So 3 times 2 is 6 square roots of 5. Okay, so we multiplied the first one, so now let's multiply the outside ones. Here, on this next one, now we're going to actually multiply the numbers under the square root, because that's the only thing we have in this square root of 3 is the number under the square root. So this would multiply to be 3 from our 3 right here, and then we multiply the numbers inside the square root. Square root of 5 times square root of 3 would be square root of 15. All right, now we multiply the inside ones. Again, here we'd be multiplying numbers outside the square root, so minus 4 square roots of 3. And finally, we multiply our last ones. Here, we're going to multiply numbers under the square root. So we have a 2 minus 2, and then square root of 3 times square root of 3 is going to be square root of 9. All right, now we got to see, can we simplify this answer anymore? It looks like the first term doesn't simplify at all. There's no numbers that go into square root of 5. 15 does have 3 and 5 that go in it, but neither 3 and 5 are perfect squares, so that won't simplify. 3 is a prime number. That won't simplify for our third radical. This last one will simplify, though. Square root of 9 we know we can simplify, so we know square root of 9 is the same as 3, so 2 times 3 would be 6. There is no more like radicals to add together. That would be our final answer. Let's look at another one. Let's multiply on this one. So on here, we're going to do the same thing. We're going to multiply. 5 times 5 is going to be 25. Also, we're going to multiply the numbers under the radical. 3 times 3 is 9. All right, let's multiply the outside ones. Well, here we're only multiplying the numbers outside the radical. 5 times 6 is 30 square roots of 3. Now we're going to multiply inside ones. Again, only multiplying numbers outside the radicals. Negative 6 times 5, negative 30 square roots of 3. And finally, the last ones. Negative 6 times positive 6, negative 36. Now we look to see, is there any like terms or any simplifying we can do? Well, first off, we know that 25 will be multiplied by 3 because square root of 9 is 3. These middle terms can be added together. They are like terms. They both have a square root of 3. And if we got the same number, positive 30, negative 30, these would actually cancel out. So keep simplifying. 25 times 3 is going to be 75 minus 36. And our answer would then come out to be 39. So all that multiplying up there comes down to be 39. That's this type of multiplying. If you look at number 14, what we were multiplying together, notice that both terms are the same. 5 square roots of 3 and 6, they got the same numbers. The only difference is one is minus, one is plus. When we multiply like this, these are called conjugates. So anytime you have the same numbers, just different signs, it's called a conjugate. And what happens when you multiply with conjugates is you always get rid of all your radical terms and you get a whole number answer. The reason I bring that up is we're going to use that to simplify this next one. This next term, we have a numerator and denominator. There's not really anything we can simplify right off the bat. It's not okay to just cancel these square root of 3's. We can't do that because these are whole terms. It's like they're in parentheses. You can't just separate them out. So we can't do any easy simplifying like that, but we're not supposed to leave radicals in the denominator either. So how do we get rid of this square root of 3 in the denominator? Because we're not supposed to do that. So what we can do is multiply by the conjugate. If we multiply by the conjugate, you can get rid of that radical in the denominator. So the conjugate to the term in the denominator would have the same two numbers, 5 and square root of 3. You just pick the opposite sign. So this one has a plus in our original problem, so we're going to multiply it by 5 minus the square root of 3. Now you can't just multiply the denominator by something. Whatever you multiply the denominator by, we're also going to have to multiply the numerator by the same thing. All right, so now we got some multiplying we're going to do here. Some FOIL. So let's multiply through. Let's do the bottom first. If we multiply the bottom, 5 times 5 is 25. If we multiply the outside ones, minus 5 square roots of 3. The inside ones would be plus 5 square roots of 3. And the last one, we would have, it'd be negative, positive, and a negative, and square root of 3 times square root of 3 would be square root of 9. All right. On top, we got some multiplying too. If we multiply those through, we're going to get 5 minus square root of 3 minus 5 square roots of 3 plus square root of 9. Now what we do is simplify. Simplify the numerator and simplify the denominator. If we simplify the denominator, notice these terms cancel, and that will always happen when you do a conjugate. So what we end up with in the bottom is 25. And we know square root of 9 is the same as 3, so 25 minus 3. On top, these two square root of 3 terms we can add together. We got negative 1 square root of 3 and negative 5 square root of 3, so we got 5 minus 6 square roots of 3. And we also know square root of 9 is also 3. So finally, simplifying a little bit more, our final answer, we have 22 on bottom, and on top we have 8 minus 6 square roots of 3. And now we no longer have a radical in the denominator. There is one last thing we could do to simplify this one. Notice all of our terms here, 8, 6, and 22. There is a number that goes into all those 2, so we could cancel out a little bit. We could divide everything by a 2. 2 goes into 22 11 times, goes into 8 4 times, 2 goes into 6 3 times. So the most simplified answer would be 4 minus 3 square roots of 3 over 11. Now you no longer have radical in the denominator and it's simplified. All right, we'll try some more of those in class when you come back.